Hello everyone, myself Avinash Rangaraju, Department of Pharmaceutical Chemistry, Assistant Professor. Right, today we'll have an elaborative discussion on one important reaction called as Claisen-Schmidt reaction. So Claisen Schmidt reaction. Right. So before we go into the inner mechanism of this particular reaction, we need to understand what is the basic statement of this reaction, what is the general reaction, and then we will study what is the mechanism of this particular reaction. So first, let me define what is Claisen-Schmidt reaction. So it is nothing but a carbonyl compound without alpha hydrogen was reacted with another carbonyl compound with alpha hydrogens in the presence of a base to form alpha, beta unsaturated aldehyde. So this is nothing but your cinnamaldehyde. What we call the final product will be cinnamaldehyde in this particular reaction. Okay, now you see the reaction carefully. Claisen-Schmidt reaction is nothing but a carbonyl compound. You know, carbonyl compound can be an aldehyde or a ketone. Without alpha hydrogen, I'll explain what are alpha hydrogens in the reaction, was reacted with another carbonyl compound with alpha hydrogen in the presence of a base to form alpha, beta unsaturated aldehyde, which is nothing but the cinnamaldehyde. In very simple way, you are going to take two carbonyl compounds, right? So one carbonyl compound doesn't have any alpha hydrogen. Another carbonyl compound will have alpha hydrogens. Now these two carbonyl compounds, you are going to react them in a base, okay, to form alpha, beta unsaturated aldehyde, so which is nothing but your cinnamaldehyde. So in this reaction, you can take either an aldehyde or a ketone. If you take a ketone as a starting material, the final product will be your ketone only. You will get alpha, beta unsaturated ketone. Okay, so let us see the general reaction of this Claisen-Schmidt reaction. So I'm going to take one aldehyde. So you know this is benzaldehyde, right? And this is without alpha hydrogen. Plus, you are going to take another carbonyl compound with alpha hydrogen. So example, I'm going to take acetaldehyde. And it is with alpha hydrogen. Now, these two carbonyl compounds, you are going to react in the presence of a base. So I'm going to take sodium ethoxide. So the final compound will be This is alpha comma beta unsaturated aldehyde. So this is also called as commonly cinnamaldehyde. Okay, right. Now I'll try to explain this reaction. So I have taken one carbonyl compound, that is benzaldehyde, without alpha hydrogen. First, you listen what is meant by alpha hydrogen first. Okay. Now look at here. What is this group called as? So this is called as aldehyde functional group, right? So the carbon atom which is present adjacent to the functional group, this carbon you can call it as alpha carbon. But to this alpha carbon, there are no hydrogens attached. Okay, so whenever there is a substitution on this carbon atom of your aromatic ring system, the hydrogens will be lost. Okay, so the carbon atom which is present adjacent to the functional group, you can call it as alpha carbon. Okay, so but this alpha carbon is not having any hydrogens. So this is your benzaldehyde. Next, this benzaldehyde, I am going to react with another aldehyde with alpha hydrogen. Now you see this is your functional group, right? This is your functional group, aldehyde. Now the carbon atom, okay, which is present adjacent to the functional group, you can call this carbon as alpha carbon. And the hydrogens which are attached to this alpha carbon, they are called as alpha hydrogens. Okay, now this alpha carbon is attached with 3 hydrogen atoms. Now all the 3 hydrogen atoms are called as alpha hydrogens. Okay, so you are going to react 2 carbonyl compounds. One is without alpha hydrogen, another one is with alpha hydrogen in the presence of a base like sodium ethoxide. Okay, to get the final compound, that is alpha comma beta unsaturated aldehyde. So again, look at here. This is your aldehyde functional group, right? So the carbon atom which is present adjacent to the functional group, this is called as alpha. The next carbon atom will be beta. So that's the reason it was called as alpha comma beta unsaturated. There is a double bond here. Okay, so that's the reason you can write unsaturated. And what is the functional group present here? Aldehyde. So this is a structure for your cinnamaldehyde. Okay, now what we need to understand is how you are going to get this unsaturation, how CH double bond CH is formed here. So this is what we need to understand. So this we have to take into consideration, and we have to understand the mechanism for the formation of this unsaturation and how the CH double bond CH is formed here, and how these 2 aldehydes are reacted together in the presence of a base. So this we can understand by taking the mechanism of the reaction. Okay, so the mechanism proceeds in 3 important steps. Okay, step number 1 is formation of carbanion. That is carbon which contains a negative charge. Okay, so how can we form this carbanion? Listen carefully. So I'm going to write the structure of acetaldehyde first. So I'm going to write the structure of acetaldehyde in this way: CH2, H, C double bond O, hydrogen. Plus I'm going to react with sodium ethoxide, which is a base here. Now, what happens is you compare the electronegativity between carbon and hydrogen. Carbon will have slight slightly more electronegativity. So the electrons which are present in the sigma bond will migrate towards carbon. What happens to this hydrogen here? Hydrogen will get positive charge. Now, here the oxygen will have two lone pair of electrons. Okay, so this lone pair of electron you can donate for this hydrogen which is having positive charge. So therefore what happens, this oxygen will form a new bond with hydrogen. So ethyl alcohol or ethanol can be liberated as a byproduct. Apart from that, what is there? The sodium ion will be extracted out and you'll be left over with CH2. Okay, I'll write the lone pair of electrons with a negative charge here, C double bond OH. Okay, now how you got lone pair of electrons for carbon? As I told you just now, due to the electronegativity difference between carbon and hydrogen, the electrons which are present in the sigma bond will migrate towards carbon. Therefore, the electrons I have designated with carbon with a negative charge. Okay, so this is nothing but your carb anion, which is your step number 1. So next we'll go for the step number 2. I'll erase this statement here. And I will take this reaction also. Right. So in step number 2, what will happen, we'll see. Okay. So what is step number 2 now? Step number 2 is nothing but nucleophilic attack on the positively charged carbon. Okay, so I'm going to write the same carbanion structure here once again. CH2 with a negative charge. Right. Now already one aldehyde with alpha hydrogens I have utilized in step number 1. In step number 2, I am going to utilize another carbonyl compound without alpha hydrogens. That is nothing but your benzaldehyde. Okay. Now, what is step number 2? Nucleophilic attack on the positively charged carbon. So first we need to generate a carbocation. Okay. How can we generate a carbocation? It's very simple. If you compare the electronegativity between carbon and oxygen, oxygen is more electronegative. Therefore, these pi electrons will move towards oxygen atom and this carbon will get positive charge. So to stabilize this carbon, which is having electron deficiency, okay, this carbon is having lone pair of electrons. Okay, in carbanion structure, the carbon atom is possessing some lone pair of electrons. So this lone pair of electrons will be shifted towards the positively charged carbon. Therefore, a new sigma bond will be formed between the aldehyde carbon and the carbanion. Okay, so if you look at the structure here, you can understand. So you can write the same benzene ring followed by this CH. So as you shifted one pi bond towards oxygen, you will get only single bond oxygen with how many lone pair of electrons? You will get 3, because when you shift this pi bond, oxygen will get one extra lone pair of electron. Originally, oxygen will have only 2, but when pi bond is shifted, you will get one extra lone pair of electron. Okay, so next you can write the same structure, CH2. C double bond O H. The same structure I have written here. Now, this is a new sigma bond which is formed between the aldehyde carbon. This is your aldehyde carbon and this is your carbanion. Okay. Next, this intermediate compound I'm going to react with ethyl alcohol. Where from you are getting again this ethyl alcohol? So ethyl alcohol is the byproduct which is liberated in step number 1. So the same ethyl alcohol I'm going to write here in step number 2. So due to the electronegativity difference between oxygen and hydrogen, the sigma electrons will migrate towards oxygen and this hydrogen will get positive charge. Okay, so this positively charged hydrogen can be stabilized by using this extra lone pair of electron which is present on oxygen. So oxygen will donate its lone pair of electrons for this hydrogen. Therefore, what happens? This hydrogen will migrate slowly towards oxygen to form OH. Okay, so you can write the benzene ring here, CH. Now, OH will be formed with oxygen only 2 lone pair of electrons followed by CH2, C double bond OH. Okay, plus what is the byproduct you're going to, once again, you will get ethoxide anion with 3 lone pair of electrons. Why? Because when sigma electrons migrates to oxygen, in general, oxygen will have only 2. But when these sigma electrons are migrated towards oxygen, oxygen will get 1 extra lone pair of electron. So totally it will be 3 lone pair of electrons on oxygen. And this is called as ethoxide ion. Okay, so this is your step number 2. It's very simple here. Okay. So what is happening here? You are taking the carbanion, which is formed in step number 1, reacting with benzaldehyde. So here we are going to generate a positive charge for carbon by migration of this pi electrons towards oxygen, as it is more electronegative. Therefore, this carbon will get positive charge. So positively charged carbon can be stabilized by using these lone pair of electrons present on the carbanion. Okay, so these electrons will be shifted towards the positively charged carbon. Therefore, there is a new sigma bond formation between the aldehyde carbon as well as the carbanion. Okay, so this intermediate compound, once again, you are going to react with ethyl alcohol, which is a byproduct in step number 1. So the same ethyl alcohol can be used here, and the bond is broken between oxygen and hydrogen due to electronegativity difference. So the sigma electrons will migrate towards oxygen, making hydrogen electron deficient. So as oxygen is having 3 lone pair of electrons, this oxygen will donate 1 lone pair of electron for this electron deficient hydrogen atom. Therefore, OH will be formed. So this oxygen will take away the hydrogen atom from here to form OH. Okay, and rest of the structure is same, CH2, C double bond OH. Plus you are going to eliminate ethoxide ion outside with a negative charge. Okay, next, coming to step number 3, the last step involved in the Claisen-Schimdt reaction. I think so far it is clear, right? So we'll go for step number 3 here. So step number 3 is dehydration, followed by formation of cinnamaldehyde. Okay, so I'm going to write the same structure once again here. Phenyl ring, CHOH, okay, CH2, C double bond OH. So What is the first step is dehydration. You know, dehydration is removal of water molecule. So here OH is a very good leaving group. It can leave the reaction by breaking the bond between carbon and oxygen. So this OH will leave it with a negative charge. Okay. At the same time, whenever there is an electron withdrawing group, aldehyde, the adjacent hydrogen will become more and more acidic in nature. Therefore, one of the hydrogen atom in CH2 will become acidic and it will carry a positive charge. So this positively charged hydrogen and negatively charged OH minus combines together to liberate a water molecule. Okay, so when OH leaves the reaction, what happens to this carbon here? Carbon will get a positive charge. Okay, at the same time, the electrons which are retained with this carbon, it will be shifted here to form a double bond. Okay, so that means when you compare the electronegativity between carbon and hydrogen, carbon will have little bit more electronegativity, right? So carbon will have some lone pair of electrons with it. So these lone pair of electrons will be donated for the next carbon atom to form a double bond. So that means if you remove one hydrogen, you will get one double bond here. So you will get the same phenyl ring system, CH, double bond CH, CH2, double bond oxygen and H, that is aldehyde. So this is called as cinnamaldehyde, okay, which is also called as alpha comma beta unsaturated aldehyde. So this is your aldehyde functional group. The carbon atom which is present to aldehyde, adjacent to the aldehyde functional group is called as alpha. Okay. Sorry, there will be no CH2 here. So here you'll be getting CH, double bond CH and aldehyde. So this is your aldehyde functional group. The carbon atom which is present adjacent to the aldehyde functional group, you can call it as alpha. The next carbon will be beta. So it is called as alpha comma beta. As there is a double bond, it is unsaturated aldehyde, which is also called as cinnamaldehyde. So step number 3 is very simple. Here it is dehydration. So you're having a free hydroxyl group here. So when you break the bond between carbon and oxygen, this entire OH group will leave the reaction with a negative charge and this carbon will become positive. At the same time, due to the electron withdrawing nature of aldehyde group, the adjacent hydrogen atoms will become more and more acidic, and therefore these acidic protons can also be having positive charge, and one of the acidic proton which is having positive charge reacts with OH minus to form water. So if you remove one hydrogen atom, there will be a formation of a double bond here, CH double bond CH, and the same aldehyde group I have written here, which is called as cinnamaldehyde, also known as alpha comma beta unsaturated aldehyde. So this is about your Claisen-Schmidt reaction and its mechanism. Thank you.